Hi kids, now we'll be going with this paper discussion. You can look into the first question. The first question says, the potential energy function of a particle of mass m as a function of displacement is given. So you need to find angular frequency of small oscillations. I think there was a typo here. It would have been corrected by the time you will be writing exam. So potential energy function is given. So you need to find force. You will be differentiating minus du by dx will give you the force. So you will be differentiating it. So but you will be ending up with minus beta sine x. So this won't be SHM, but for small displacement sin x is almost equals to x. Now you can see force is proportional to displacement. So you can find acceleration is proportional to displacement. So this is like a equals to minus omega square x. They are asking what is omega, right? So everything you have to convert it to a equals to minus omega square x form. The second one, the blocks of masses 3 kg, 6 kg are connected at the ends of massless spring of spring constant 800. The spring is initially compressed by 6 centimeter and then released. The time period of oscillation of the blocks and the amplitude of 3 kg mass. So all these kind of questions you'll be doing it this way. Generally the easiest way of doing it is pull them in such a way that their center of mass won't be moving, like this m into this displacement equals to this m into this displacement. That way you won't be moving the center of mass, right? So then once you pull it by distance capital X, and if you pull this down by a small x, small m into small x equals to capital M into capital X. Then if you look at the extension of the springs, extension of the spring will be capital X plus small x. Now you can write F equals to ma for any one block. I will be going to write for this one. The net extension is small x plus capital X. So the force will be k times of small x plus capital X, that equals to mass times of acceleration. Acceleration of this particle is double differentiation of this displacement. But there is capital X, I have to convert this capital X into small x. So what I will be doing, I will be using this small x equals to capital X equals to small m into small x by capital M. Instead of capital X, I will be substituting it and I will be modifying, and I will be getting x double dash equals to, actually it has to be negative sign, right? Because displacement is in this direction, blocks will be going in the opposite direction. So x double dash is proportional to displacement but in the opposite direction. This is omega. Now this one people will call it as reduced mass and stuff. So once you, then you will be getting the time period or something like this. Now you can directly use this result, right? Even if you don't know, like you can follow the same method. So result will be this much instead of mu m1 m2 by m1 plus m2. K value is given. So when you substitute, you will be getting the time period. Now what about the displacement? You will be moving in such a way that center of mass won't be moving. 3 into displacement of 3 equals to 6 into displacement of 6, like you are compressing, right? Such that center of mass won't move. And x3 plus x6, total compression is 6 given. So from here you can solve for x3. That way you will be getting option 2. Next question is, they have given y as a function of x and t, velocity of the particle. So this particular particle, you need to find the velocity, that is y coordinate is moving, like y coordinate is moving with time. So that is, you need to differentiate with respect to time. You need to look at one particle. What is that particle? X equals to 2. So concentrate on x equals to 2 and look at the video of that particle. Look at the video of that particle. That particle will be moving up and down with respect to time. That is, you need to find how it is varying with respect to time. So you need to find dou y by dou t, where x value is fixed, right? So y is given. Now you need to find dou y by dou t. Why dou y by dou t? Because x value is 2 fixed. We are looking at the video of x equals to 2. So x value is fixed. So when you differentiate this, differentiation you must be knowing, right? Differentiation of this one is minus 1 by x square. Differentiation of 1 by x is minus 1 by x square. But this differentiation is again this much. This differentiation is again this much with respect to time. X is constant you will be taking. Now then you need to substitute x equals to 2 and t equals to 1. When you substitute the values, you will be getting almost the required answer, right? 0.0336. The only difficulty here is differentiating properly, where x is constant, 3 is variable. Now you can look at here, this is constant, so differentiation of this one is 0, this is the variable, so minus 3t differentiation is minus 3. Going to the next question, a simple pendulum of length L is suspended from a wall at an inclined angle B alpha. Now pendulum is displaced by beta and beta is greater than alpha. So alpha will be somewhere here if you want. So if this wall is not there, it would have gone somewhere here. But because of this wall, what will happen? It will hit here, and assuming no energy loss. So with whatever speed it will be hitting, it will be coming back. If this is not there, it would have performed one full SHM and the time period will be t by 4, t by 4, t by 4, t by 4. But now t by 4, less than t by 4, less than t by 4 and t by 4 will be getting. That less than t by 4, how much we need to calculate? Now how we are going to calculate it? We will be using the general equation. If something is performing SHM, x equals to a sin omega t, right? Amplitude is beta and x is Yeah, alpha. So what is the time from here to here I am calculating? Mean position thing is this one, right? So I am trying to calculate what is the time from here to here. How much I got it as 1 by omega. From here I will be getting this one. Omega is 2 pi by t. So this is the time from here to here. Now from here to here again it's the same time. So if I go, this is t by 4. From here to here it is this much. From here to here again this much. From here to here t by 4. That you can see, right? T by 4, this thing, t by 4. T by 4 from here to here, this thing from here to here, this thing from here to here, t by 4 from here to here. So this is the required answer, where t is 2 pi into root of L by G. Next question goes like, one train is approaching an observer at rest and other train is receding from him with the same speed. Both the trains blows whistles. The beat frequency as heard by the observer. So that's a straightforward question, right? One train is approaching, so you will be hearing more frequency. One train is going away, you will be hearing less frequency, and you need to find what is the difference that is going to give you the beat frequency. Every value is given in the question. All you need to do is just substitute the values. A particle executes simple harmonic motion along x-axis with amplitude a. At t equals to 0, the particle is at x equals to minus a by root 2 and its velocity is positive. The displacement function as a function. Okay, you need to find that. Now I will be drawing the phasor diagram. Some particle is here at x equals to minus a by root 2 and it is going in this direction. If I want to look at it like a phasor which is moving in clockwise direction, I can look at it like this particle. If I take this particle, then it is at x equals to minus a by root 2, but velocity is in the negative direction. So I will be taking this point which is moving in this direction, right? Now it is this is a by root 2, they said, so this angle is 45 degrees. I can easily find this is a by root 2, this angle is 45 degrees. Now after some time this will be rotating by an angle omega t. Then what will happen to this angle? It will become 45 plus omega t. If this angle becomes 45 plus omega t, what will be the horizontal component? It will be a sin a cos 45 plus omega t. A cos 45 plus omega t, but its coordinate is negative, so minus a cos pi by 4 plus omega t, 45 plus omega t. Or I can say this angle is going to become 45. Now it is 45, later moment it will become 45 minus omega t. If this angle is 45 minus omega t, then this component is going to become a sin 45 minus omega t, but again its coordinate is negative, so I will be putting minus. So either of these two will be going to be the answer. So this is given in the option, so you can mark it, right? Yes, it's the same thing. Minus, when you take inside, it will become omega t minus pi by 4, omega t minus pi by 4. 3 SHMs having unit amplitude and same frequency, the phase difference by pi by 4 with each other, the amplitude of the resultant motion. This is very straightforward question. I mean, if you know the result, you can add those SHMs like vector quantities, right? Amplitude 1 and making an angle 45 degrees, one more, and 45 degrees, one more. Resultant of these two is root 2 in this direction. That root 2 and this one will become 1 plus root 2, right? So what is the total amplitude? Root 2 plus. When a stationary wave is formed, then its frequency is, you people must be knowing it, it goes like this, right? One wave in the forward direction, one wave moving in the backward direction. When they combine, still you will be getting the standing wave with the same frequency thing, right? Same as individual waves. Now the next one, 3 pendulums have length ratio 1:4:9. The time period of shortest pendulum is t. At t equals to 0, all the 3 are at mean position going in the same direction. This will occur again after what time? Time period is proportional to root L. So L1 is to L2 is to L3 is given 1:4:9. So time period ratio will be root L1 is to root L2 is to root L3, which is 1:2:3. And they said first time period is t. Then the second time period will be 2t. Third one will be 3t. Now what is the GCD? I mean greatest common divisor. It is going to be 60. So after 60, everything will be coming to the same position, again the same thing. That you can see, right? After 60, in the sense it would have performed 6 full oscillations. This would have performed 3 full oscillations. This would have performed 2 full oscillations. Now everything came back to the same point and moving in the same direction. The equation, this particular equation, it represents a wave with amplitude, frequency, wavelength they have given. So whenever they give square thing, convert it into linear form. They have given cos square. So I know cos 2 theta equals to cos square minus sin square, or I can write as 2 cos square minus 1, right? 2 cos square minus 1. From there cos square will be 1 plus cos 2 theta by 2. So cos square will be 1 plus cos 2 theta by 2. I will be expanding it, and you can see this will be the wave with mean position a by 2, right? From a by 2 you will be getting that wave kind of thing. That's fine. So amplitude. Now this is 2 pi by t or 2 pi f, right? So this coefficient will be 2 pi f. 2 pi f is 4 pi n. So from there frequency is 2n. Now this is 2 pi by lambda. Lambda in the sense wavelength. 2 pi by wavelength of the wave. But wavelength of the wave I am calling it as x. Lambda is some other constant what they assumed. Lambda is not the wavelength. This x thing is the wavelength. 2 pi by x equals to 4 pi by lambda. So x equals to lambda by 2. So what is the wavelength? Wavelength is lambda by 2. Frequency is 2n, right? So there you will be ending up with option 1. A standing wave pattern is formed on the string. One of the wave equation is given by this. So what will be the other one such that x equals to 0 will be a node. What does it mean by node? Its displacement has to be 0 anytime. So initially I tried guessing from the options. It's like if it has to be node, it has to be node at any time. So at x equals to 0, it must be node at any time. So at t equals to 0 also it must be node. When I substitute t equals to 0, y1 is a cos pi by 3 I got. Now t equals to 0, x equals to 0, first option will turn out to be this much. When I substitute x equals to 0 and t equals to 0, first option will become this much, second option will become this much, third option will become this much, fourth one will become this much. Now if I add y1 and y2, the displacement has to be 0 because it is a node, right? But when I add these two, it won't be 0. When I add these two, it won't be 0. When I add these two, it will become 0. When I add these two, it will become 0. So I ended up with doubt over like C or D. When I check it for other option also, it is turning out to be equal, same answer for C and D. So I have to go with general solution. It's like when I add the given equation and some other equation, the net displacement has to be 0. Now from here, it's mathematics, right? So this thing must be equals to this thing. So either these two angles must be same. This is minus, right? When you take this minus inside, it will become minus pi and stuff. That is mathematics. You can manage, right? A liquid of mass m is taken in a tube with one arm bent at an angle theta with the other arm, which is vertical. If the liquid in one arm is slightly depressed and released, the liquid executes SHM of frequency. So now what you are doing, you are pressing this liquid. Now before pressing that liquid, both liquids will be at the same level. When you press it by distance x, this will go up by distance x. Now look at it like two steps. Assume I am removing this water and I am putting it here. Removing water is the first step and putting water is the second step. Before doing this, it is in equilibrium. When I remove water, I am reducing a force rho, weight of this liquid in this direction, right? What is the weight of liquid in this direction? Rho A x g. A into x is the volume, density into volume into g is the weight of this liquid. Now previously both forces are equal. When I remove this, I am reducing a force from this side, or else I can visualize it like there is extra force in this direction, right? There is a force reduced in this direction, or there is a force extra in this direction. What is the extra force in this direction? That is this part, right? When I before removing the water, both forces are equal. When I remove this water, obviously you know this side force will be more. How much more? Equivalent to this weight. Now I am putting that here. Now by putting it here, what I am doing, I am adding extra weight, but weight will be in this direction. What will be its component along the motion? Weight's component. Weight is rho into A into x into g, but this component is going to be cos theta. Now by removing this, there is some extra force, that is this much. By putting it back, there is some extra force, that is this much. Now the total force equals to mass times of acceleration. When I modify it, I will be getting A equals to omega square x form. Obviously, like displacement is, acceleration is in the opposite direction to displacement, so it will be SHM. Then you can get the time period and stuff. Everything, for every question, we need to convert it to this form, right? Beats are produced by two waves. The number of beats heard for, that's a straightforward question, right? So 2 pi f1 is 2000 pi according to the given question, right? Two equations. 2 pi f2 is this much. F1 you will be getting, F2 you will be getting. The difference in the frequencies will give you beat frequency. 2 pi f1, 2 pi f2. The distance travelled by simple harmonic oscillator in the first and second seconds are alpha and 2 alpha respectively from extreme position in the same direction. The amplitude of oscillation is. Now when a particle is starting from extreme position, then we will be writing the equation like this, right? You can check like at t equals to 0, x equals to a. Now at 1 second, when t equals to 1, this will turn out to be a cos omega. What does that mean? Particle will be at a cos omega, where this x1 is a cos omega. Now in 2 seconds, where it will be a cos t equals to 2, a cos 2 omega. That is, it will be a cos at a position a cos 2 omega. So what is the distance moved by it in first second? That is a minus x1. Yeah, in 2 seconds. See, in the first second, In the first second distance moved by it is alpha. In the second distance moved by it is 2 alpha. So what is the total distance moved in first 2 seconds? First second alpha, second 2 alpha. So totally it will be 3 alpha. So what is this distance? 3 alpha. In the first second alpha, from here 2 alpha. So totally 3 alpha. So a minus x2 is 3 alpha. A minus x2 is 3 alpha. A minus x1 is alpha. A minus x2 is 3 alpha. Now a minus x1. A minus x1 is alpha. A minus x2. A minus x2 is 3 alpha. Now we need to solve them. What I did? I know this relation cos 2 theta equals to 2 cos square theta minus 1. Now cos 2 omega I found it from this equation, I just substituted it. Cos omega I found from this equation, I just substituted it. Thereafter it's only about solving. Now just to eliminate too many variables, I just assumed alpha by a is x and I solved for x and it turned out to be half. X is alpha by a, so from here a equals to 2 times of alpha. Right? It's only about understanding the figure and solving the equations. A block of mass m is rest on another block of same mass as shown in figure. The lower block is attached to a spring of stiffness constant k, the maximum amplitude of motion, so that the block will remain contact. This block will remain contact. Now if it is performing SHM, if both are like they are remaining contact, right? So I will assume like both are moving. When both are moving, both will be performing SHM together. Now if both are performing SHM together, how many forces will be acting on it? There will be its own weight and there will be normal from the bottom block, right? Now if it is performing SHM, what will be the maximum acceleration of this guy? It will be omega square a at its extreme position, right? At its extreme position. When it is at its extreme position, the contact will be losing. That's what they gave in the question, right? That is the maximum thing. Now when the contact is losing, normal will become 0. If normal becomes 0 and if it is still performing SHM, who is the guy who can provide that acceleration at the extreme position? Mg. So at the extreme position, when it is losing contact, the only force is mg, which will be providing the required acceleration. So mg is the only guy who will provide that acceleration at the extreme point. At the extreme point, acceleration will be omega square a, right, when it is performing SHM. But this omega is root of k by 2m in this particular question, right, 2 times of mass. So from here we will be getting acceleration is g by omega square. Omega square you can substitute from here, we will be getting the required answer. Spacing between two successive nodes in a standing wave is x if the frequency of the standing wave is kept unchanged but the tension is doubled. So what will be the new wave, new successive difference and stuff. So distance between two consecutive nodes is lambda by 2. In the first case, lambda 1 by 2 is given as x. Now in the second case, lambda 2 will be v2 by f2, but what they said, we know v equals to root of t by mu. Oh, they said something 16th. If the frequency of the standing wave is kept unchanged, frequency is kept unchanged, so I am putting it as f only, that is you can assume it as f1. Tension is doubled. So when the tension doubles, what will happen to the velocity? v2 by v1 will be root of t2 by t1. Tension is becoming double, so velocity will become, final velocity will become root 2 times of initial velocity. Final velocity will become root 2 times of initial velocity. But v1 by f is old lambda. They are asking what is lambda 2 by 2, that is consecutive nodes, distance between two consecutive nodes. Lambda 2 by 2 is this is lambda 2, right? So lambda 2 by 2 is this by 2. This lambda 1 by 2 is x given, so answer will be root 2 x. Two closed organ pipes when sounded simultaneously gave 4 beats. If the longer pipe has 1 meter length, the shorter pipe length will be. Now beats is 4, so modulus of f1 minus f2 is 4. Now in this particular question, we will be taking fundamental. So lambda by 4 equals to L, lambda equals to 4L, that figure you can draw. So frequency equals to V by lambda, V by 4L. Some people will be remembering it, whatever it is. So frequency will be V by 4L. So V by 4L1 minus V by 4L2 is 4. Now they have said one length is 1 and the other length you need to find. So you just, V value is given in the question, right? You can just substitute and you can calculate for. It's a straightforward question, right? The bob of simple pendulum is a ball full of sand. A fine hole is made at the bottom of the ball through which the sand leaks out. As the pendulum oscillates, you need to find what is the time period. Now time period of pendulum is 2 pi into root of L by G. When there is a bob with full of sand, center of mass will be here. That is the length. Now when the sand is leaking, center of mass of the bob will be here, but the center of mass of the sand is going down. So net center of mass of these two things will be somewhere here. You can see center of mass shifted downwards. But I can clearly show you this is a continuous process, and in the end when the entire sand is leaking out, the center of mass is again coming to the center. So basically what you can understand, center of mass is going down for some time, and after that it will be coming up and it will settle down at the center. So length is increasing then decreasing. So time period will first increase then decrease. First increases then decreases. A ring of mass m and radius are pivoted on the rim and is made to oscillate in vertical plane about an axis passing through the pivot and perpendicular to the plane of the ring, the time period of small oscillations. So what you will be doing? You will be disturbing it slightly and you will be seeing what is happening, right? So you will be taking torque about this point. When you take torque about this point, R into mg sin theta, R into mg sin theta, torque equals to I alpha. Moment of inertia of the ring about this axis is mr square, about this axis is 2mr square, torque equals to I alpha. So for small angle sin theta is almost equals to theta. From here you can see alpha is proportional to displacement. Angular acceleration is proportional to angular displacement, but obviously in the opposite direction. When you rotate it, it will try to rotate in the opposite direction. So this is omega square, right? So when it is omega square, time period is 2 pi by omega. You can easily get it. The position of particle is given like this. You can see a square, again convert it into linear form. 2 sin square omega t, cos 2 theta equals to 1 minus 2 sin square theta. So I will be using the same thing, 1 minus cos 2 theta. 2 sin square is 1 minus cos 2 theta. So this one will turn out to be 1 minus 2 cos 2 omega t. Now this is SHM. This is SHM. Amplitude this much, time period this much, 2 pi by 2 omega. That's SHM. And mean position. This is shifted mean position. About 1. Earlier it used to happen at 0, but now about 0 it will be oscillating with an amplitude 2. Okay, x, right? So if this is x equals to 0, now it will be oscillating about x equals to 1. So it will go to at a distance 2 and it will come back and it will come back to a distance 2. It will be oscillating with an amplitude 2. About mean position x equals to 1. A block of mass 2 kg is suspended from vertical spring of force constant 200. If 1 kg mass is added to it, the spring will execute simple harmonic motion of amplitude. Okay, when the spring is at natural length, it is going to look like this. When you add 2 kg, it will be extended. Now what is that distance in equilibrium? Now spring force must be equals to weight. So kx equals to 2g. From there x equals to 2g by k. That much you can get. Now similarly, if you add 1 more kg, what will happen? This will be equilibrium position, kx equals to 3g. So x equals to 3g by k. 3g by k. Right? Now when you add 1 kg mass, what will happen? It will go from here to here. That is, mean position is shifting from here to here. Here velocity is 0. Velocity is 0. And this is equilibrium position. So what does that mean? This is going to be one extreme position. This is going to be mean position. It will be oscillating like, it will go from here. It will cross the equilibrium position. It will go down. It will come back. It will come here. By energy conservation, when it comes here, it will be at rest. So again, it will go back. It will go. It will come. It will come. So what is the amplitude? Amplitude is this much. This is 3g by k, this is 2g by k, so the amplitude will be 1g by k, 1g by k. Two trains sounding frequency 280 Hz are approaching a person on the platform from opposite direction with the same speed. If the beat frequency heard by the person is 4 Hz, when he starts walking towards one of the train, the speeds of the train. So that's also two different cases. In one case, train is coming towards him, he is going towards the train, so the frequency will increase. Like the new frequency will be V plus V observer by, because observer is moving towards the train, and so both ways, this one also has to increase frequency, this one also has to increase frequency, so plus minus. Now in the other case, man is going this way, but this train is coming this way, so train velocity will be in such a way that it will increase the frequency, observer velocity will be in such a way that it will reduce the frequency. So the difference is 4 given, all the values are given in the question, all you need to do is just substitute the values. 23rd, a spring of spring constant 300 Newton per meter is cut into 3 parts in the lengths of ratio 2:4:5. If the springs are connected in parallel to a mass 2.2 kg, that was given 2.2, the angular frequency of the oscillation. Anyway, mass is secondary thing in the question. The primary thing is you need to be knowing spring constant is inversely proportional to length. If you don't know how it came, you can visualize this thing. Young's modulus is stress by strain. From here force value will be something like this. This is like k into x form, right? So k is inversely proportional to length, or else I can say k into L is constant. K into L is constant. K value is given, total length I am assuming it as L. There are 3 springs, right? Okay, this is K2, K4, K5. Now I have taken K2, K4, K5. One length is 2 parts, next one is 4 parts, next one is 9 parts. That is 2 plus 4 plus 9, 11 parts. You are dividing the thing into 11 parts, but you are giving 2 parts to this, 4 parts to this, 5 parts to this. So what is the new length? 2L by 11, 4L by 11, 5L by 11. From there you can get K2, K4, K5, right? When you equate these two, you will be getting K2. When you equate these two, you will be getting K4. When you equate these two, you will be getting K5. So you know all these 3 spring constants. Now when you connect them like this, they are going to behave like an effective spring of spring constant K1 plus K2 plus K3. Yeah, I mean K2 plus K4 plus K5. So K2 is this much, K4 is this much, K5 is this much. So effective spring constant is this much. Then omega will be root of K by M. K by mass is 2.2. When you substitute, that's a bad calculation. You will be ending up with almost 38. So the important thing for the question is you must be knowing K is inversely proportional to length, or else K into L is constant. From there you need to find the spring constant of different parts of the spring. 24. A stretched string of length 1 meter is fixed at both ends having mass, okay, under tension 20 Newton is plucked. See, 1 meter is having mass 5 into 10 power minus 4 kg. So mass per unit length is given 5 into 10 power minus 4 kg. It is plucked at a point 25 centimeter from the end. The stretched string would vibrate. It's not wood. It's like they are going with the general common sense thing. I mean, what majority of the people will think. This is the string. You are plucking it here. So it will be oscillating with more amplitude. That is going to be antinode. So if this is antinode and this is node, this is going to be node and antinode and node. So this is what they are trying to visualize. So basically you will be getting two loops, velocity equals to root of T by mu. T is given, mass is given, and length is 1 meter. So mass per unit length is also the same thing. So from there you will be getting the velocity lambda. From here you can see lambda by 4 is 25 centimeter, or 1 lambda equals to 100 centimeter. Lambda is 1 meter. So you know V, you know lambda F equals to V by lambda. That's a direct thing, right? So the only thing is understanding how this figure is coming into picture. A simple pendulum suspended from the roof of car accelerating at a constant rate. When the car attains a steady velocity, the pendulum oscillates with an angular amplitude of. Generally when the car is not accelerating, what will happen? It will be in this direction, right? Now when the car is accelerating, you will be observing from car frame, you will be having pseudo force extra, that is m into a, which is root 3 into m into g. Now the equilibrium position will be somewhere here. If the equilibrium position, the net force must be 0, or else I can say like, I can bring this vector and I can put it here. Summation of these two vectors must be balanced by tension and stuff. So tan 60, now this angle will turn out to be 60, right? Tan theta equals to root 3 mg by mg. So this angle will turn out to be 60. So it will be oscillating with an angular amplitude 60 degrees. 60 degrees is pi by 3 radians. Next one is a mass 4 kg is attached to a spring of spring constant 250 and is executing SHM on horizontal plane. When the mass is at extreme position, another mass falls. The ratio of final amplitude to initial amplitude. That's a time saving question, right? So one is performing SHM. When it is at the extreme position, one more mass is falling. Now because of this mass falling, what is happening? Nothing is happening, because its momentum was 0. If this momentum is 0, this momentum is also 0. Now momentum conservation will happen without change in any energy, right? So what is the energy here? Half k into this amplitude square. What is the energy here? Half k into this distance square. So it will be going to the same distance and it will be coming back to the same distance. So amplitude won't be changing, right? In this case, potential energy is half k a square plus kinetic energy is 0. Now this is going to be extreme situation because kinetic energy is 0. Now potential energy, if I want to write it like half k into new amplitude square, new amplitude will be same as old amplitude, right? So 1:1. Potential energy is given. The particle is released at x equals to -3. If the mass of the particle is 0.1 kg, then the maximum velocity. Maximum velocity will happen. Maximum velocity in the sense maximum kinetic energy. Maximum kinetic energy will happen when minimum potential energy happens, because total mechanical energy will be conserved. This is the total energy. Now I need to find minimum potential energy. If I want to find where minimum potential energy will be, I have to differentiate it and make it equals to 0. I have differentiated it. I made it equals to 0. Then I got x equals to 2. So at x equals to 2, potential energy will be minimum. If I want to find what is that minimum value, I need to substitute this x equals to 2 back. When I substituted, I will be getting -18. So what is the minimum potential energy? -18, where it will happen at x equals to 2. Now I can say that potential energy plus that kinetic energy must be equals to potential energy and kinetic energy at any moment. But at initial moment they said kinetic energy is 0 at x equals to 3. So potential energy at x equals to x equals to minus 3. What will be the potential energy at x equals to minus 3? I will be substituting x equals to minus 3. When I substitute, I will be getting it as 107. So at x equals to minus 3, potential energy is 107, kinetic energy is 0. 107 plus 0 equals to minus 18 plus half mv square. Now m value is given, you can just substitute and you will be getting the required answer. On sounding a tuning fork A with another tuning fork B of frequency 384, 6 beats are produced. After loading prongs of A with wax, then sounding against B, 4 beats are produced. So let me say this is B384. So 384 can produce 6 beats with 390 as well as 378. But when you are waxing, if you wax 390, what will happen? Its frequency will reduce because mass is increasing. So its frequency will reduce. This frequency also will reduce if you wax. So if I consider these two, then the beats are increasing. The frequency difference is increasing. So the beats will be increasing between these two, but the beats will be decreasing between these two. So according to the given question, the beats are getting decreased. So they are talking about this guy whose frequency is 390. The vibrations of string of length 60 cm fixed at both ends is represented by something. The maximum displacement of string at x equals to 3. So y is given at x equals to 3. What will happen? We'll see. We'll substitute when x equals to 3. It will become pi by 6. Pi by 6 sin pi by 6 is half. So 4 into half is 2. You can see that is SHM, right? Obviously that particle will be performing SHM with amplitude 2. The ratio of average value of potential energy with respect to position. Averages can be like various ways, like time average, position average and stuff. So they are talking about position average with respect to total energy. So any average will be given by u. If it is time average, u dt by dt. If it is position average, u dx by dx thing, right? So I will be taking from only one quarter, that's sufficient enough because all the 4 quarters will look the same way. I will be integrating from 0 to a, 0 to a. Potential energy is half k x square. This integration is simple. Now this is x cube by 3, which is a cube by 3. Now when you see it, you can see like half k x square. Half k square is the total energy. So this is total energy by 3. Now ratio is 1 by 3. 1 by 3 is given as 2 by n in the question, and they asked what is the value of n. N value is 6, right? Yes, that's all right. Thank you.